Okay, so let's continue to do some more simplification. Again, the idea is we're using two rules, right? We're using the fact that I can take a radical and break it up into pieces. I'm using the fact that if my power matches my index, the radical basically clears out, right? And again, we're assuming everything is nice and positive. And so that's basically the idea. So when you break things up, you can use that guy, and we have shortcuts and everything in between. So looking at this guy, first let me go ahead and use what we've been doing. The index is 2. And so basically we have to break everything up into powers of 2. So x to the 7th, well, that would be an x squared, an x squared, an x squared, and an x, right? 2 and 2 and 2 and 1, that all adds up to 7. Y to the 6th, well, that's a y squared, y squared, y squared. And z to the 8th is a z squared, z squared, z squared, z squared. And so why am I breaking everything up into 2's? Because my index is 2. Now officially what's going on is we're breaking this up into pieces. So we got the square root of x squared, square root of x squared, square root of x squared, square root of x, square root of y squared, square root of y squared, square root of y squared, square root of z 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 squared. All right, so we have an x, an x, and an x, and a square root of x. We have a y, and a y, and a y. We have a z, a z, a z, and a z. All right, and so basically everything wipes clean. We got x cubed, we've got y cubed, we have z to the 4th, and then the only thing remaining in the radical is a square root of x. So that's doing it the long version. Of course, rather than breaking it up, you could have just seen that, right? Here's an x, here's an x, here's an x. There's a y, there's a y, there's a y, there's a z, there's a z, there's a z, because all the powers match the index. So I'm kind of skipping that step. And of course, if you want to use the fractional exponent idea, check this out. This might even be a bigger shortcut. The square root of x to the 7th, y to the 6th, z to the 8th turns into x to the 7th, y to the 6th, z to the 8th, all to the 1/2 power. And now when I work with my exponents, right, we have a power of a product, and we also are multiplying exponents. So we get x to the z over 2, y to the 6 over 2, and z to the 8 over 2. This guy, if we think of this fraction, 2 goes into 7 3 times with remainder of 1/2. 2 goes into 6 3 times, and 2 goes into 8 4 times. So we can see that little extra half applied to that x. So we have x to the 3rd, y to the 3rd, z to the 4th, and technically x to the 1/2 power. Of course, what is that 1/2 power? Square root of x. So there's our answer yet again, using our fractional exponents as a shortcut. So you pick what you like. You can do it the longhand form with a little bit of a shortcut. You can use fractional exponents to help you out. It all works, whatever you're comfortable with, whatever seems to make sense to you. But what we're doing is breaking things up and using the fact that a power and an index, if they match, they wipe each other clean. That's basically what I'm using all over the place. So in our next example, let me begin by taking 32 and rewriting it as 2 to the 5th. And then we have w to the 9th, p to the 8th, and z to the 10th. I'm going to try my fractional shortcut first before we do anything else. So all this is to the 1/3 power. Of course, this is a power of a product, so we can distribute that power and multiply. So we get 2 5 over 3, w 9 over 3, p 8 over 3, and z 10 over 3. So I'm just converting these all to their fractional exponential form. 5/3, well, that's 1 2/3. This is w to the 3rd. 8 divided by 3, well, that's 2 2/3. All right, and then 10 into 3, or 10 divided by 3, that would be 3 1/3. So any whole numbers give us a power. So we have 2 to the 1st, w to the 3rd, p squared, and z cubed. And then any fractions, right, we end up with a 2 squared p squared z to the first, and all that stays underneath the radical. So there would be the shortcut. Of course, the longhand version is to take all of this, right, and break it up into threes. So 2 to the 5th, that's 2 to the 3rd times 2 squared. W to the 9th, well, it's W to the 3rd, W to the 3rd, W to the 3rd. P to the 8th, well, that's P to the 3rd, P to the 3rd, and P squared. Z to the 10th, that's Z to the 3rd, Z to the 3rd, Z to the 3rd, and Z. And we're taking the cubed root of the entire thing. So if we were to break it up, which I'm not going to do because that's going to be crazy, but if I broke it up, right, there's a power that matches an index, so we get a 2. Right, here's another power that matches, another power that matches, another power that matches. So we get W to the 3rd. Here's a power that matches, here's a power that matches, so we get P squared. Another power, another power, another power, so we get C to the 3rd. What's left underneath the radical? 2 squared, P squared, and Z, just like I predicted. So you pick how you want. The top version is kind of a really quick shortcut where I'm just kind of thinking in terms of fractional exponents. This is the longer version where we're breaking it down literally into powers that match the index and just clearing them out. So whatever works, okay? The next one, first off, we have to be careful because we have a bunch of plus signs. Notice over here in the last couple examples, everything was a product. So I don't even have this in play right now, right? This only works if I have a product underneath a radical. Then I can break it up. That's what the rule says. It doesn't say I can take a sum and break it up into pieces. So seems like we're a little stuck. However, let's go back to chapter 5. We know how to factor this. First thing we need to look for is a GCF. So there's a GCF of 9. And when I factor that away, what I end up with is 9 times x squared plus 4x plus 4. Next, if we take a look at this, this is a perfect square trinomial, and that breaks up into x plus 2 times x plus 2. So putting this all together, 9, well, that's 3 squared, and this is x plus 2 squared, and we're taking a square root. Of course, if we break each piece up, the power matches the index, so we're left with a 3. Here, the power matches the index, so we're left with x plus 2. And again, we're assuming everything's nice and positive, so that's why I'm not going to use the absolute value. So that's what allowed us to finally simplify this, and it actually simplified very nice because there's no more radical. That's really nice. Here we still had a radical, and here we still had a radical, but this simplified so nicely we have no more radicals, so that's really nice. But again, we can't break a radical up into sums and differences, but we can break up radicals for products. And so that's what we try to use. We either have the product we can break up and use the rule, or we have some factoring skills we can use, break it up into a product, and then I'm up to there. So there's a lot of simplification. It's going to be a major issue throughout Chapter 10. I'm pretty sure we're going to do a lot of practice at it. So let's keep on moving forward.